us understand what cloud is very easily without any big words. And guys, so modern application runs on cloud. So I actually Googled this before I started this video. Roughly 54 to 72% of all enterprise workloads run in public or hybrid cloud environments, with over 90% of newly adopted, developed modern applications built on cloud native platforms. So the question is why? It could be Google Cloud, it could be AWS Cloud, Azure Cloud, GCP, Microsoft Cloud. You work at your job, or iCloud services, your data, your backups on your iPhone. Let us understand what cloud is without complicating it. So if you are not following this video and you are just trying to understand cloud, that's fine. You would catch up in less than 60 seconds. I just want to have the guys that watched the previous video understand. So in our last video, we talked about virtualization and servers, right? And everything we talked about boiled down to the fact that if a company wanted to implement virtualization, once they buy their physical servers, they would have to install a hypervisor here and virtualize this server so they could run multiple virtual machines on this server. But there's something we didn't talk about. So what we didn't talk about is that, okay, you as the company, once you buy the physical server, right, you have to get a data center, right? So this server has to stay somewhere, which is why we keep hearing of data centers all the time in the news, on the internet, wherever. I don't know where you get your information, or if you are active out there, you keep hearing of data centers, right? So all these data centers basically host or house all of these physical virtual machines. And because they are there, someone has to manage it. So let's say I start my company, right? Yannick, Tech for Yannick, and I need virtual servers. I would need to actually go rent a space. I would rent a physical space, right? I would go rent a physical space. It could be a storage or a warehouse. In the warehouse, I would go place my servers. So I would be responsible for electricity for the warehouse, rent for the warehouse. I would have to pay for engineers to go routinely and perform maintenance for these servers, patching, updates. Let's say the server goes down, something is wrong. I would have to have people go do this because it's my server, right, for my company. So this management here is a problem, and most companies were starting to do this a lot. So what happened over time, right, and what really moved us to the cloud, which is basically all of this here. See, this is what we was doing with virtualization, running multiple virtual machines on one physical server. This helps us with hardware abstraction, meaning that we could use one same hardware resources for multiple virtual machines that are running on the same hardware. Resource efficiency, because we have one big server which runs multiple thousands of virtual machines, making the resource utilization fast. Now, everything runs on one infrastructure. All of these are the benefits of virtualization, right? But virtualization did come with its own drawback and its own headaches, which is what cloud computing solves. And so with cloud computing, what happened is the biggest providers in the market, which is basically AWS, which is owned by Amazon, Azure, which is owned by Microsoft, and Google Cloud, basically GCP, owned by Alphabet or Google. So there's other cloud providers such as Alibaba Cloud, Oracle, and all these other little players in the market. But basically, what these players did is companies started finding the process of like managing the virtual servers and data centers expensive, right? So a company would have to pay for a physical location and they have this, all of this here right here is expensive, guys. So what these large players here started to do, right, is that they started buying a lot of land all over the world. Literally, they started buying so much land, and on the land they started building physical data centers, right? So they started building data centers, and in the data centers they started installing all of these servers, right? Virtual, they started installing physical servers, and on the physical servers they would install hypervisors, right? And then now what happens is companies such as Tech for Yannick, companies such as example.com, companies such as LinkedIn, companies such as Excalibur, any company on the internet that needs a server, rather than going through this process that we used to go through back in the day, where we have to buy it, we have to find where we are going to host it. Hosting, not like hosting as a website, basically where we would place it, where the server would reside. So we would have to place the server somewhere. We would have to take care of maintenance. So all of that is a lot. We are trying to make money in our company. We don't want to deal with all of this. It costs a lot, and this server is even more. It's super expensive. So these big players build. They bought a lot of land, but thousands of servers. They are still doing it today. Install the servers, and then now companies such as me and other companies that need compute power, right, that need compute power or need virtualization servers, we would actually just get a little piece of the virtual servers, right? So this is really what cloud computing is. So once they built the servers on the physical environments, whenever we need a server, we could actually log into an online platform with a UI, and then after doing a couple of clicks, boom, that's it. You have a virtual server provision. But that virtual server, remember, a virtual server is always hosted on top of a physical server. So these physical server components, thousands, hundreds of thousands, millions of them are built and installed in physical data centers. Guys, I know it can get complicated, but it's easy. A lot of these servers are built. Let me actually Google. Let me see. Physical data center. I want these concepts to hit home, right? Okay, see for example, right? All of these servers right here, right? This is a data center, right? This is a data center. So what happens is Amazon, Google, GCP, so they have millions of these. And then on top of these, trillions of virtual servers are running in here. This is an example of a data center. So think of this or imagine of this at scale. Imagine that there are millions of data centers like this, which have millions of all of these physical hardware components or servers. And on top of all of these servers, hypervisors are being installed on all of them. And on the hypervisors let us to be able to run millions of virtual machines on top of these physical servers. Now, these physical servers are being assigned with physical server components such as hardware component, memory, and whenever you request to create a virtual server, what happens is you are being issued a little resource on one of the physical data centers somewhere in the world, right? So now all of these companies that basically do virtualization or offer cloud services, it revolves around four main things. Four main things. Let me try to type it. So the four main things, all of these really revolves around. It comes down to compute. So they are actually selling compute as a service, which with compute as a service is basically all the machines. So they are selling you virtual machines. You can go to Amazon. You can go to either AWS, Azure, or GCP, create an account, log in, and after clicking doing a couple of clicks, and we are going to do that. If you stick on the channel, you're going to see us doing that in our next video. So you do a couple of clicks and then boom, you specify, hey, I want 2 GB of RAM, I want 10 GB of storage, I want a Windows server or Linux server or an Ubuntu server, and within seconds you get you get a virtual machine provided to you. So that is selling compute. Another service that most of these providers really sell is storage. So with storage, they are basically um, helping us with remote storage so that with application files and data and pictures, videos all over the internet, remember modern applications do generate a lot of data, and this data has to be stored and saved somewhere. So that is with storage. Another one is databases. Databases help us with storing information so that we could retrieve them on demand when we need them in our applications virtually in the back end. You don't want to deal with it on-prem. And another fourth, which is most important component that cloud services help us with is networking. So networking helps us to have your compute, your storage, and your databases all talk to each other, connect to each other, which forms all of this big giant thing we all call the internet and applications and how things interconnect and work with each other. So the benefits of cloud is that you don't need to buy these physical servers. You don't need to manage them. You can actually all you need is internet access and internet connection and a laptop, just like I have here. You could go on the internet. Actually, if you want to set up a free AWS account, just look up free. Just type free AWS account, sign up, follow the prompts. Make sure you go on the official link, right? On the official link right here, aws.amazon.com. And then you get your free $200 credits if you are trying to learn. I already have my account open, but we are going to deal with that. But basically, you go on the platform, you create an account, you click all over the place, and before you know, you do have a virtual server that is provided to you. And on the virtual server, you can use it to actually create or do whatever you want to do. And whenever you don't want the virtual server, you could actually do your couple of clicks again and delete it. So these cloud providers are actually helping us with creating virtual servers without having to buy the physical component of a server, without having to deal with the maintenance of the server, without having to deal with paying the rent for physical storage of a server, paying the light, electricity bills. So it's a managed service. So all of these companies that need virtual servers, right? Instead of these companies building their own data centers, right? So Amazon builds the data centers. Tech for Yannick, I might have a virtual machine here. You watching this video, I don't know what your name is, but whoever you are, you set up a business, you could have a VM running in here. By the way, if you go on Amazon, right, and you request to get a virtual machine, Amazon might give you a virtual server that resides here on this server. If I go request, I could get one that's here, I could get that one that's here, or I could even get a partition on here. We could be working on the same virtual machine without knowing. But the logical isolation is what makes us to not even know about it, right? So that's how it works. And talking about scalable and flexible is because if you need Amazon has no limit. Amazon, GCP, cloud, all of these cloud platforms, they typically have no limit as to the cloud services they could provide for you. If I want 1,000 virtual machines, I'm sitting right here on my computer, on my laptop, on my phone, right? If I want 1,000 virtual machines, all I have to do is log into any of these platforms that I want. I choose that I like. And once I log in after a couple of clicks, I could get a virtual machine provisioned. And if I'm tired, I don't want the virtual machine no more. I don't want to, and I pay for it only per usage. So it's pay on demand. That's why here we see on demand services. I pay as I use it. If I stop using the virtual machine, I don't have to pay for it. So I did not pay for a virtual server. I don't have to worry about, I don't want to use the virtual server. I have to um, um, update it. I have to patch it. It's expensive. So this is much more easier. Now we talk about public cloud and private cloud and hybrid clouds. So public cloud is basically with the concept that I did explain. Like if I log in, if I go to my Amazon account and I request to set up an Amazon virtual machine, which is basically compute, an EC2 instance, elastic compute, um, which we would explain. Okay, so this is what I would do, right? After this video on cloud, I will start another series on AWS cloud dedicated. In the first video there, I would still explain this, but not a little bit like this. This is basically for you to just understand what cloud is. This is a foundational video, but we would focus on Amazon. I would make a lot of videos on Amazon cloud. Why? Because Amazon, as of 2026, they still have the greatest market share. They have over 29% of cloud services. And if you want to study cloud or DevOps, you typically want to start with learning the services that have the largest market share, as it's going to give you the most opportunities. So we would do Amazon Cloud. Maybe after we would do Azure and GCP. I don't know. It actually depends on how I feel. But and yeah, but we are going to start Amazon Cloud next week, just so you can be able to understand this. And we will understand public versus private cloud. But just so you know, with public cloud, it's just all about like I'm sitting on my machine, on my computer right here. I'm trying to create a virtual machine on Amazon cloud, right? You trying to create a virtual machine. We are both accessing the public cloud. Now, if you want a private cloud, is basically you making sure that Amazon dedicates, let's say, this server only to you, so that you make sure that no other company, no other person, I cannot come and host my services here. Now, that is the difference of a public and a private cloud. So this is it about today. If I had to repeat everything and make it so simple, guys, cloud is a logical concept. There is no such thing as your files or your servers live up in the sky. That's what I want to say to conclude this video. There is no such thing. Cloud just basically means that server that you are accessing or at any given time. And remember, servers host applications, they host files. It could be your Google files or whatever. That server, when they say when something is said to be in the cloud, it just means that it is somewhere that you cannot see. For example, I could be right here and they say, and I'm accessing a cloud instance, and that the physical server is downstairs in my basement. It's still the cloud. It doesn't mean it's not the cloud. Cloud just means that I'm accessing something virtually that's not here is being hosted in a remote backend, which could be in India. You could be accessing this YouTube page, and this content is hosted in the cloud. Now the cloud server could be in India, it could be in Australia, it could be in California, it could be anywhere. That is the whole concept of cloud.